An isosceles triangular plate of negligible thickness has base 25 mm long and altitude 35 mm. It is placed on HP such that in the front view is seen as an equilateral triangle of 25 mm sides, with the side that is parallel to VP is inclined at 45 degrees to HP. Draw its top and front views. Also determine the inclination of the plate with the reference planes. So an isosceles triangular plate has its base of 25 mm and altitude 35 mm. So you have a base of 25 mm and the altitude means the height, which will going to be the perpendicular distance with respect to the base, which is 35 mm. It is placed on HP. So it is placed on HP such that its front view is seen as an equilateral triangle. So since he has given the front view, so we have to start the problem from the vertical plane. So now here first initially we are keeping an isosceles triangular plate with one of its points on the horizontal plane, which is base of 25 mm long, and you take the midpoint of this and then draw a perpendicular line to a height of 35 mm and complete the triangle, isosceles triangle. So when you look from the top view, we can see that all the sides are parallel to VP, so you are getting the true shape in the vertical plane. And when you look from the top view, you have perpendicular to HP, so in HP we can see that it will be a line. So this is the initial position of the isosceles triangular plate. We can see here, which is 25 mm base. It is resting on C dash on HP, so that the base is 25 mm and the altitude is 35 mm, and such that the surface is parallel to VP. So that is the reason why in VP you are getting the true shape, and it is perpendicular to HP, so that is the reason why you are getting a line in the top view. So as we see from the top view, A is near to the observer and B is near to the observer, so A and B is visible and C is away from the observer, so it becomes invisible. Similarly, when you look from the front view, that image will go to fall on the vertical plane A dash, B dash and C dash. Now in the second position, as we see here, when we rotate such that its front view is seen as an equilateral triangle. So we are rotating with reference to the vertical plane. So when you are rotating such that its front view becomes an equilateral triangle. So in the front view you have to write the equilateral triangle, and then by your taking this distance, you cut it so that you will going to get the rotation, and you determine the inclination of this with respect to VP, which is 51.79 degrees. When you are doing it in computer, when you are doing it in manual, it will be 52 degrees. So that it is rotated such that its front view will going to become an equilateral triangle, which is A dash, B dash, C dash. So that is what we have shown here in the equilateral triangle. And here also, when it is in space, when you are rotated, so this is the rotation angle, so that you will be able to get the equilateral triangle when it is rotated in the initial position when it is 35, and then it is being rotated nearer to VP, so that you will going to get an equilateral triangle. It can be rotated either nearer to VP, or it can be rotated away from VP, but such that you will going to get the equilateral triangle in the front view. Then with the side that is parallel to VP is inclined at 45 degrees to HP. So which is the side which is parallel to VP? When you look from the front view, when you look from the top view, we can see that B dash, C dash is the line, which is BC. Both are equidistant from the vertical plane. So obviously that side will be parallel to VP. So that side is parallel to VP, is inclined at 45 degrees to HP. So now he has given the true inclination. Since it is parallel to VP, so you are going to get the true length in the vertical plane, that is B dash, C dash will going to be in the true length. Because it is parallel to VP, you are getting the true length. The true length of that line will be equal to 25 mm. So when it is projected, you will going to get 25 mm here also. So that is the reason why we can say that it is in true length. And the inclination is also given the true inclination. Therefore, you rewrite the second position front view by rotating at an angle of 45 degrees. When you rotate by an angle of 45 degrees and then write the corresponding top view, so this will going to be the position. So here also we are doing the same thing. When you are rotating that BC by an angle of 45 degree with respect to HP, then we will be able to write the projected surface onto the top view. This will going to be the projected surface on the top view, and this position and this surface will going to remain the same, and this is the projected surface into the vertical plane. So this is how you can be able to analyze both in 2 dimension and also in 3 dimension. Now we will going to solve the problem in the sketchbook. So to do that, first we will going to draw a horizontal XY line with a thin line, and you mark XY and VP and HP. Then first, since we have to start the problem from the front view, first consider any point on the XY line. Through this you measure 25 mm and draw a perpendicular to XY. Then you take the midpoint of B dash and you mark the point as B dash and C dash, and you measure and you take the midpoint of 25 mm and you mark this point. From this point you measure 35 mm and draw a perpendicular line to B dash C dash, and you measure 35 mm from here to here, that is the perpendicular distance, and you mark this point as A dash. Then join A dash to C dash, A dash to B dash, and B dash to C dash, and this will go to become the isosceles triangle of 25 mm long base and 35 mm altitude. So now when you look from the top view, we can see that 2 endpoints are equidistant from the vertical plane. So and since this entire surface is perpendicular to HP, so we will go to get a line in the HP. So first you take any distance from the XY line and you draw a horizontal line. Then you draw a vertical projector from A dash to that line, and also from B dash C dash to that line. And when you look from the front top view, A and B is near to the observer, so AB is visible, and C is away from the observer. C will going to begin in bracket. So join A to B with a dark line. Now as he says that it is rotated such that its front view will become an equilateral triangle, so you draw a horizontal projector from B dash and C dash, and you take any convenient distance and draw a vertical line, so that you will going to get this B dash and C dash. So again, this is also 25, and here also this is 25. It is an equilateral triangle. Since this line is 25 mm, so you have to get an equilateral triangle, so of 25 mm, and by taking the compass with C dash as center, now you draw a horizontal projector from A dash, and with C dash as center, take a radius of 25, cut an arc on this horizontal projector projected from A dash. Similarly with B dash as center, cut on the previously drawn arc such that it both will going to coincide with the horizontal projector drawn from A dash. So this is how you will be able to get this point A dash, and then draw a vertical projector from A dash to the top view, and draw a vertical projector from B dash C dash to the top view, and draw a horizontal projector from B and C, so that the vertical projector drawn from B dash to C dash will going to cut this point here, and you mark this point as B and C in bracket. Then you take the distance from B to A of the first position top view with B as center, cut an arc on the vertical projector drawn from A dash in the second position front view, so that you will going to get this point A. Once you mark the point A, join A to B with a dark line. So by using the protractor with B as center with reference to the horizontal, you measure the angle which will going to be called as phi. So phi will be equal to 51.79 when you are doing it in computer. When you are doing it in manual, it will be 52 degrees. Then the edge which is parallel to VP. So which is the edge which is parallel to VP, or which is the side which is parallel to VP, which is B comma C, B of C, because when you look from the top view, B and C is parallel to VP. So that is the reason why you are getting different, you are getting the true length in the vertical. So the inclination given to this side is true inclination, and the length is also true length. So obviously we need to rewrite the same sketch by rotating at an angle of 45 degrees. So to do that, consider any distance from the second position front view, and you mark that point as C dash, and then by using the protractor with C dash as center, with respect to the XY line, you measure an angle of 45 degrees and then draw an inclined line. Then by using the compass with C dash as center, take the radius of 25. From C dash, you cut an arc on that 45 degree line, and you will going to get this point as B dash, and you mark the point as B dash. Similarly, with C dash as center, draw an arc of 25 mm arc, and similarly with B dash as center, cut an arc on the previously drawn arc, so that you will going to get this point A dash. Then join A dash to B dash to C dash, and C dash to A dash with a dark line. Now to write the top view, draw a horizontal projector from A and draw a vertical projector from A dash. Both these 2 points will going to intersect at this point, and you mark this point as A. Similarly, draw a vertical projector from B dash and draw a horizontal projector from B. Both will going to intersect at these 2 points, and you mark the point as B here, and draw a vertical projector from C dash and draw a horizontal projector from B. Both these 2 points will going to intersect at this point, and you mark the point as C. Then join A to B, B to C, and C to A with a dark line. So this is how you will be able to solve the problem in the sketchbook and show the dimensions of 45, and this is 25. It's an equilateral triangle, and this side of base 25 mm, and this is 35 mm. So this is how you will. And now, how do I know that this is the problem we have considered? So one of the corner points of the isosceles triangle is resting on HP, and the side which is parallel to VP, that is BC, is inclined at 45 degrees to HP, and it is an equilateral triangle of 25 mm, and he has to determine the angle with respect to VP, which will be 52 degrees, and also it is a isosceles triangular base of 25 mm and altitude 35 mm. So since we have considered all the parameters given in the problem, hence this will going to be the